Hello, I'm Jim Lovell. The films you're about to see describe space missions in 3 of the most astounding flying machines ever built. One, the Space Shuttle, is launched like a missile, flies like a spaceship, and then lands on a runway like an airplane. The next is a 2-part machine that made possible landing on the moon and, of course, getting back to Earth safely. The third is a 570-pound robot, the first man-made object to fly beyond all the known planets. This volume of America's achievements in space, compiled by the Eastern Press, takes you along on each voyage by means of dramatic, first-of-their-kind films. You'll see the shuttle launch and its flight from all angles, including airplanes chasing it and from onboard cameras. You'll watch weightless astronauts perform graceful somersaults and see breathtaking views of deserts and mountains from 170 miles up. The shuttle Columbia looks much more like a magnificent flying machine than Spider and Gumdrop, nicknames given to spindly moonlander and its wide mother ship. These craft flew together for the first time on Apollo 9 in March 1969. If Spider wins a first prize for its odd appearance, then Pioneer 10 gets the award for longevity. Launched in March 1972, the instrument-laden robot gave people on Earth their first close-up look at Jupiter and its exotic moons. Now that was in December 1973. Almost 10 years later, in June 1983, it flew beyond the edge of the solar system. You're about to see the intriguing story of Pioneer 10 and its sister ship that gave us our first close view of Saturn, its rings, and its moons. So sit back and enjoy the machines, the stories, and the pictures. Let your imagination savor the possibilities as astronomer Carl Sagan tells you about a plaque aboard Pioneer 10. It describes the inhabitants of planet Earth and our location. The message was written just in case the remarkable robot flies long enough and far enough to encounter other intelligent life.
Sunday, April 12, 1981, Kennedy Space Center, Florida. The Space Shuttle, 14 stories high, 2,000 tons, poised on the pad for its maiden flight. This is Columbia, the spaceship that will orbit the Earth. Its external tank, it holds over 500,000 gallons of fuel for Columbia's 3 main engines. And the solid rocket boosters, the largest ever used on any launch vehicle and the first to be employed in a U.S. manned flight. At liftoff, the solid rocket boosters, together with the 3 main engines, will unleash more than 6.5 million pounds of thrust needed to launch the world's first reusable spacecraft. Never before has a winged vehicle been launched like a rocket, orbited the Earth, returned through frictional heating in excess of 2,500 degrees, and landed, still aerodynamically sound, to be launched again and again. If it succeeds, the Space Shuttle will truly be a remarkable flying machine. There are many other goals to be reached during the 54.5-hour mission that lies ahead. 144 test objectives are planned for the flight. These objectives could not be achieved without an astronaut crew. The commander, John Young. The pilot, Robert Crippen. Young has already been in space 4 times for a total of 533 hours. He is the most experienced astronaut flying today. Although Crippen has over 4,000 hours of jet aircraft flying time, this will be his first time in space. The astronauts make their way across the access arm toward the shuttle in the pre-dawn hours before launch. An American spaceship has never carried a human crew on its maiden voyage. At the Launch Control Center, 3 miles from the pad, final steps are being completed in the countdown. Final preparations are also being made in the Mission Control Center in Houston, where control of the flight will switch once the shuttle clears the tower.
Okay, now your vent switch to open until the
There has not been a manned launch from Kennedy Space Center since the Apollo-Soyuz test project in July of 1975. With this launch, Young and Crippen, launch controllers at the Cape, and flight controllers in Houston will experience the most dynamic, fast-paced series of launch events ever undertaken in the space program, all in less than 9 minutes. The most challenging ascent profile ever to be flown by a space vehicle. Photographers, film and television crews, plus newspaper and magazine writers from around the world, nearly 2,700 of them are here to cover the launch. In addition, approximately 600,000 spectators line the coastal area near the Kennedy Space Center. Arriving by every mode of transportation, they have come from every state in the Union and many foreign countries. The promise of a rebirth in America's manned space program and the dawn of a new era in space transportation awaits.
14, 13, T-minus 10, 9, 8, 7, 6, 5, 4. We've gone for main engine start.
Roger, roll.
The roll will put the shuttle on its precise heading toward an imaginary target in space.
Roll program complete.
Roger, roll complete.
Get a status. Vital. Go. Booster. Go. GNC. Go. Eagle. Go. Go at 40, Capcom. Columbia, Houston, you're go at 40.
The shuttle is now 40 seconds into flight.
Roger, Columbia, on the nice ride. You're lofting a little bit. You'll probably be slightly high at staging.
Negative seats.
Columbia, you're negative seats.
Should anything go wrong, the shuttle is now too high for the astronauts to use their ejection seats.
Columbia, you're go for SRB SEP.
We see SRB SEP flight. Roger, on a SEP. 103 converge flight. Duet. Capcom, let's tell them all the calls are going to be a tad early because of the hot first stage.
Columbia, you're looking a little hot. All your calls will be a little early.
Okay. Okay, map looks good here.
Stand by, press to MECO.
Columbia, stand by. Press to MECO.
Mark it.
Mark. Press for MECO.
Roger, press for MECO.
The shuttle can now continue toward MECO, main engine cutoff.
They like the VAP, Eagle. ECOM. Let's go, flight. Capcom, VAPs go. Stand by, negative return.
Columbia, stand by for negative return.
Mark it.
Mark. Negative return. And your VAP is good.
Outstanding. Sure is. We can confirm it. What a view.
And single engine rotor flag.
And Columbia, your single engine rota.
Columbia can land safely at the Naval Air Station in Rota, Spain, even if 2 of the 3 main engines should fail. Right now, the engines are generating over 42 million horsepower.
Miko 25, 6,
Miko.
0 up at 220.
Roger, Miko. And we got Miko confirmed. Miko
Roger,
confirmed,
Columbia,
and it's
Miko.
right on the money, nominal.
Main engine cutoff. Columbia is now in space, traveling over 18,000 miles per hour.
Okay, we got set.
Roger, and we confirm the step, Columbia.
The external tank has just been jettisoned and is now falling away from the shuttle back toward Earth. The tank will break up as planned over the Indian Ocean when it comes into contact with the atmosphere. Shortly, by firing the OMS, Orbital Maneuvering System engines, Columbia will achieve orbit. Then one of the most important tests of the mission will be attempted, opening the payload bay doors. The doors must be opened before the end of the 6th orbit to expose the space radiator cooling system. If the radiators cannot be exposed, heat collected from the onboard electronics cannot be released, and the astronauts will have to return home. The OMS burns are successful. Columbia is now in orbit, circling the Earth at an altitude of approximately 150 miles. The payload bay doors will now be opened.
Okay, the port door's coming open now.
Roger, copy.
Well, you are missing one fantastic sight. Boy, that is really beautiful out there.
We appreciate those updates.
Both doors have been opened. The radiators can be deployed to begin dissipating the heat.
The doors are all opened up and hunky-dory. Labs are deployed right on time.
And the radiators look good.
Okay, we want to show you our own pods here. We do have a few tile missing off of both of them. Off of the starboard pod, 3 tile and some smaller pieces, and off the port pod, looks like I see 1 full square and looks like a few little triangular shapes that are missing, and we're trying to put that on TV right now.
Roger, Crip, we can see that good.
From what we can see of both wings, tops and leading edges, though, all those are fully intact.
Within minutes, an assessment is completed on the impact these missing tiles could have on the remainder of the mission. At a news conference later in the day, Flight Director Neil Hutchison answers questions from reporters.
Well, you asked me if I knew where there were any other tiles that might be loose. The answer is no. And quite frankly, we're not worried about any other tiles being loose.
At this writing, is there anything at all that would lead you to say you might not go for a full duration mission?
Nothing.
Columbia, Houston, you guys did so good, we're going to let you stay up there for a couple of days. Your gopher on orbit.
Spacecraft must go for on orbit. This thing is just performing just outstanding.
Roger, we agree with that. And Columbia, Houston, just for your information, you dropped those SRBs right on target, and they were floating just the way they ought to be, and the boats were getting ready to fish them and bring them back.
Okay. The ride that they gave us was pretty neat.
The solid rocket boosters, which separated from the Columbia as planned 2 minutes 11 seconds into the flight, landed on target in the Atlantic Ocean, 151 miles downrange from the launch site. After being towed back to Kennedy Space Center, both boosters will be refurbished and used again in a future shuttle flight. The third and fourth Ohms burns are also successful, raising Columbia's orbit to an altitude of approximately 172 miles. For the first television transmission from inside the spacecraft, the crew will give a status report on the mission.
The flight so far has gone as smooth as it could possibly go. We've done every test that we're supposed to do, and we're up on the timeline, and the vehicle has just been performing beautifully, much better than anyone ever expected to do on a first flight, and no systems are out of shape. And it's delightful up here in zero gravity, my dad. Of course, we owe this to a lot of people, and we certainly want to thank everyone who has helped get this thing airborne, and can take great pride in it's doing so well right now. Okay, we're switching over to the aft camera here. Yeah, I'd like to echo John's words as I usually do. I guess being the so-called rookie on this flight, I had a thrill from the moment of liftoff all the way up to what we're doing now. It's really been super. The spacecraft has worked as advertised all the way along. I think we've got something that's really going to mean something to the country and the world. This vehicle is performing like a champ, like all of us that have worked so long on it knew that you would.
Okay, sir, we appreciate those comments.
I guess that does it.
That was a good time, and I think you must have practiced. We're just about to lose your ghost song.
Just accident.
Just accident, says Robert Crippen. None of the other events of the day have been accidental. Every test, liftoff, SRB separation and recovery, ET separation and impact, 4 ohms burns, payload bay door latch opening and closing tests, radiator latch deploy and stowing tests have all been successful.
I guess we owe you guys one super attaboy for today. This is fantastic. You worked through a pretty long, hard day, and you're essentially right on schedule, which is going to be close to being a first sort of spaceflight biz, I think, for first day activities. It's sure been fun working with you today, and we look forward to seeing you in the morning. I hope you get a good night's rest.
Okay, you guys did super work today. See you mañana.
Roger, thank you. See you tomorrow, guys.
Well, many hours went into this thing. A job well done by the Shuttle space team. We can't say she's sleek and lean, but I'll tell you right now, she's a mean machine. The Columbia, not the kind you smoke. This here's a bird.
Morning, Columbia. Welcome to day 2.
All right. Appreciate that super wake-up music this morning. Well, we sure enjoyed it. This was a good breakfast.
Today, the astronauts will test onboard systems and also review procedures for tomorrow's landing. A test of the flight control system is conducted by John Young. The flight control system operates Columbia's aerosurfaces, the elevons, body flaps, rudder, and speed brake. These surfaces are useless in the vacuum of space, but will be essential tomorrow when the shuttle lands. This will require precision maneuverability, which the aerosurfaces provide. Payload bay door cycling tests help ensure that latching and closing procedures can also be done before entry tomorrow. As with every mission, many pictures of the Earth are taken by the astronauts. Over 500 on this first shuttle flight. Active volcanoes, cloud formations, alluvial fans, giant whirlpools over 15 miles in diameter, sand dunes 1,500 feet high, running unbroken for hundreds of miles. The high Himalayas, where mountain peaks reach 24,000 feet. And one of the most remarkable space photographs ever taken of the Earth, an area in Iran exposed to wind erosion, which has resulted in these breathtaking silt and sandstone formations that look more like a painting than a desert. After lunch on the second day, the astronauts receive a phone call from the Vice President of the United States, George Bush.
How's it going up there? Everything rocking along all right?
Spaceship is just performing beautifully.
Well, it's great, and everybody views it, I'm sure, just as the forerunner of great things to come. I think your trip is just going to ignite the excitement and the forward thinking from this country, so I really just wanted to call up and wish you the very best.
We certainly appreciate it, Mr. Vice President.
The crew also don and check out the ejection suits they will wear during entry. Young, Crippen, and Columbia pass every test. They are ready for the final phase of the mission, entry and landing. April 14th, 1981. NASA's Dryden Flight Research Center on the edge of Rogers Dry Lake Bed in California. A recovery convoy of 24 vehicles and more than 100 personnel are assembling here to power down Columbia after landing. Enormous crowds are also beginning to arrive. A string of traffic 6 miles long waits to enter the base. Thousands more are already here. Close to 500,000 people will eventually be on hand to see the landing. On board, the astronauts suit up for entry. The ascent and orbital phases of the mission have gone extremely well. Now the final phase must be completed. Before that begins,
Columbia, you have a go for payload bay door closing.
the doors, which have been open a total of 47 hours during the flight, must now be closed. Then, using the RCS thrusters, Columbia will maneuver into deorbit burn attitude, head down and backwards, fire the OMS engines one last time, and descend into the Earth's atmosphere.
Nice and easy does it, John. We're all riding with you.
Columbia is out of contact during the OMS burn. Mission Control will not know if this burn was successful until they are in communication with the spacecraft over Australia. It is now over the Indian Ocean on the other side of the world, but from that distance the burn must be precise so that later Columbia will hit the lake bed target in California.
Columbia, this is Houston through Yargady. We're standing by.
Burn was on time at nominal reserve 110.
Columbia is now committed to entry. With an RCS post-burn maneuver and several firings, it is oriented to a heads-up, nose-first attitude headed toward entry interface. This is where the atmosphere begins, at approximately 400,000 feet. From that moment until the shuttle reaches 165,000 feet, it will be in communication blackout, out of touch with Mission Control for almost 20 minutes. The landing site is almost 4,400 miles from entry interface. Chase planes are preparing to take off. One will call out altitudes and check Columbia for any damage just prior to landing. When the shuttle touches down here, it will be traveling at 216 miles per hour. Right now, it's going more than 17,000 miles per hour. Before it lands, it must slow down, lose energy, and it must survive the intense heat caused by traveling through the atmosphere at such a high rate of speed. Several S-turns or roll reversals are used to slow down and maneuver Columbia through the atmosphere. This one is done at 256,000 feet when it is traveling at more than 26 times the speed of sound. This one is done at 208,000 feet. During these two roll reversals, entry heating is most severe, with temperatures reaching 2,500 degrees some places on the vehicle. The aluminum skin will melt at 320 degrees. The silicate tiles must insulate the vehicle from the tremendous heat. Since there is no test facility on Earth to simulate the aerodynamic and structural environment Columbia is in right now, only calculations could be used to predict what would happen during this phase of the flight. The predictions and calculations had to be right.
Hello there, Houston, Columbia's here.
Hello, Columbia, Houston's here. How do you read?
Flying clear, and we're doing Mach 10.3 at 180 AS.
And we couldn't agree more, John. Your state vector's good. We've got good data in-house.
Okay.
The entry trajectory, velocity, and position look good. Columbia is heading for home, now only 470 miles away.
More left RCS, but okay.
Right, we're showing a roll. And John, we're showing you rolling right. Looking good.
Right, normal roll.
We're showing him crossing the coastline flat.
Columbia, we show you crossing the coast now.
Right here. We can come.
The shuttle is first sighted at about 100,000 feet with a long-range camera from Anderson Peak, California.
What a way to come to California.
In flight, Fido, I still look perfect right on the nominal.
Roger that. Out of 112K, 4.8 Mach.
We're seeing this in a row.
We see Delaz 21 degrees.
A roll reversal is done over Bakersfield, California.
Oh, that's beautiful.
Trace has a tally.
Roger, checking.
And we're seeing 1.3 Gs coming around the hack.
Roger that.
The astronauts are making the final turn to line up with the runway.
Columbia, you're really looking good. Right on the money. Right on the money. And turning on to final, your winds on the surface are calm.
I kind of win.
You're right on the glide slope, Columbia.
Yeah, clear, John.
Looks real good underneath. Everything looks real good.
Chase reports no tile or other damages evident underneath the shuttle. Columbia's altitude is now just over 5,000 feet.
Pretty clear.
Without power, Columbia must land. It cannot make another attempt.
They're coming. They're down. Feet. 40, 30, 20, 10, 5, 4, 3, 2, 1, touchdown. Those gears come. 5, 4, 3, touchdown. Look above, skipper.
Columbia's on the roller.
Welcome home, Columbia. Beautiful, beautiful.
You want us to take it up to hangar, Joe?
We're going to dust it off first.
This is the world's greatest all-electric flying machine, I'll tell you that. It was super.
Okay, convoy's on its way.
Convoy on. We'll stop on the Columbia. We'll stop.
The maiden voyage of Columbia has been a success. The astronauts and the vehicle have met or exceeded all 144 flight test objectives. The integrity of all the systems, propulsion, avionics, structural, flight control, power, and thermal, have been affirmed. John Young's comments after returning home.
I can't tell you what a tribute that is to the American working man and the American working woman, too. You can't imagine the variety of people who worked on this vehicle, from all walks of life, all capabilities and limitations. It's all due to their individual efforts. They proved that they can do the job. They proved it for the world to see. And I'm mighty proud to be associated with folks like that.
What a tribute indeed. The Columbia represents an achievement in aerospace technology and development never before realized in the history of manned spaceflight. It is our basic building block for the future.
It's what we've been trying to do for the last 10 years. We've got a vehicle with a payload performance that will allow us to do that, much cheaper than we've been able to do it before. It will immeasurably improve the defensive capability of the country. It will help develop space science and technology. When we get operational, the space shuttle will be able to do in 5 to 10 years what it would have taken us 20 to 30 years to do otherwise. We couldn't do it if we didn't have the space shuttle and that payload capability. And the sooner we do those things, the better off the country's going to be.
A revolutionary new era in space transportation has just begun. Routine access to space. Welcome to the future.
Spider and Gumdrop are spaceships hidden atop this rocket. Officially, Spider is a lunar module that one day soon will touch down on the moon. Gumdrop is a command module, a mothership that travels to the moon and orbits, while two astronauts descend in a Spider to the surface. The three Apollo 9 astronauts riding into space in Gumdrop have a prime mission to test Spider in preparation for its job to land men on the moon. Assigned as lunar landing module pilot is Russell Schweikert, a civilian on his first space flight. Pilot of the command ship Gumdrop is Colonel David Scott, a space veteran of Gemini 8. Boarding Gumdrop is Colonel James A. McDivitt, veteran of Gemini 4, now the first U.S. commander ever to have responsibility for the simultaneous flight of two spacecraft and the team of three to man them both.
And there we now have an open tunnel, and we have in the command module 3 people and 3 pieces of equipment, each of which is about the size of a people. And with 6 of us in there, it is really crowded. One of the difficulties in learning how to operate these mechanisms is the weight. Primarily, it gives us the capability to transfer from one vehicle to the other through a pressurized tunnel.
I think it's important to realize that that Jim and I end up leaving Dave in a 3-man spacecraft, which takes 3 men to run it.
When we first got these 2 spacecraft, I figured, well, if it's so hard to train for this spacecraft, and we now have 2, it should only be 2 times as hard as this. But I found out, much to my amazement, that it's much more difficult than 2 times the old training problem. Because I have to learn how to fly this one, I have to learn how to fly this one. Then I have to learn how to fly these 2 together. Then I have to learn how to fly them this way, and some other way. And there's so many different modes that we can get into that we really have more than just 2 configurations. We probably have somewhere between 8 and 10 or 12 maybe. When we consider the S4B and the ascent and the descent stage and the command module and the service module and the different ways we can hook them together.
You've got a lot of variables there.
Right. So it's very difficult to train for this mission.
In a simulator, the astronauts practice docking Spider with a full-scale model of Gumdrop. The real thing looks even stranger.
It's the most unaerodynamic shape I think I've ever seen. Matter of fact, all the models I see, the models have nice straight sides, and they're hard and they're rigid and everything. And the first time I saw a real LEM, I looked at it and it had what looked like cellophane sides and aluminum foil roof, and I thought, oh, they're kidding. But it's really, that's what it really is. But it doesn't need to be strong. It doesn't need all those aerodynamic shapes on the outside because that's not its mission.
I mean, relatively within the mission, which of the maneuvers are more critical?
Well, obviously, the untethered EVA with a LEM probably is, because the LEM goes to 90 miles. It has no heat shield and no tether. So it's essential that the LEM returns to the heat shield.
One thing that we should keep in mind is that only one of these vehicles has the capability to land. Safely, I guess I should add. They both have the capability of landing. We only have one set of parachutes and one heat shield. Standard launch, we don't expect it to be any different than any preceding launches or any launches that'll follow us.
T-minus 25 seconds and counting. All aspects still go at this time as the computer monitors. 20 seconds.
If we thought this was dangerous and it was critical and there were high risk, we wouldn't do it.
Go. GBM. GBM, go. Bermuda.
Guidance release 15, 14, 13, 12, 11, 10, 9. We have ignition sequence start.
In orbit, the Apollo 9 astronauts are beginning 10 days of the most complex mission ever attempted in space. This film is the visual result of the mission's complexity, views of the flight and the men.
From the third stage, it's turned around and is now stationed.
From Gumdrop, now separated from the rocket, the astronauts inspect Spider, then dock with it to spring it free from the rocket section, now visible below the skirt of the Spider. Inside Gumdrop, the astronauts prepare for first Schweikert, then McDivitt to enter the LEM. In their weightless world, up is where your head happens to be, and moving around can be fun. Fourth days, McDivitt and Schweikert pass through the tunnel into the Spider and transmit television pictures to the ground. Now, on the fourth day, they will don pressure suit helmets for Schweikert's spacewalk on the exterior of the Spider.
Schweikert, proceed up floor. Good, your camera on there, CMP? It's running. Okay. In the golden slippers.
Outside Spider, Schweikert is standing on its porch.
Okay.
Dave Scott has opened Gumdrop's hatch just a few feet from Schweikert's position on Spider.
Oh, there. Oh, dear, that looks comfortable. Oh, boy, what a view. That's spectacular. It really is. There's some food right over there. Okay, good. Why don't you, say hello to the camera or something? Hello there, camera. Oh, very pretty. But things are still falling out up there. What are you doing, throwing everything overboard? Oops, there goes a nut. Okay, what are you talking about me again? Okay, pull in. Okay, Davey, you ought to start getting your hatch closed. Say again? Better start getting your hatch closed if you're not already doing it. Oh, it's closed. Locked.
On the fifth day, McDivitt and Schweikert give Spider its crucial test flight, undocking from Gumdrop to maneuver 100 miles out before attempting to find their way back to the vital docking with Gumdrop and its capability to return them to Earth. McDivitt and Schweikert see Gumdrop and Scott fall away as they fire Spider's moon descent engine. At 86 miles, the part of Spider that will remain on the moon, a small launch platform, is cast off. For the try to return to Gumdrop, Spider fires its moon ascent engine. With McDivitt at the controls, Spider moves in to try the crucial docking to reunite himself and Schweikert with their heat shield, parachutes, and Dave Scott. Success. And Scott sees his friends emerge from the tunnel happy and tired. But they can all relax a bit now, as Spider is fired off into its own orbit, and the astronauts begin 5 days of valuable scientific Earth photography, navigation, and systems checks. After 10 days in Earth orbit, Gumdrop prepares for its fiery re-entry into the Earth's atmosphere.
to be called heavenly bodies. Our local star, prime mover of the earthly environment, father of all life. Our almost twin satellite, phasing predictably through the night. Small wonder both were regarded as gods by the ancients. Today we know the moon as a place. Now picture, if you will, a fantastic world where not one, but 12 moons crisscross the sky, 4 of them moving backwards, 4 others the size of small planets. This is Jupiter, largest member by far of the Sun's family, monarch of the outer planets, 1,000 times the size of Earth. In fact, twice as large as all the other planets combined. It is nearly a small star, a second sun, Jupiter, named for the Roman god of gods. To our eyes, it reveals only its dazzling cloud tops, rivers of wild color, and its trademark, the great red spot, a perpetual storm of unknown origin. On Jupiter, day and night are each less than 5 Earth hours long, and a man would weigh 500 pounds. In early 1972, mankind launched Pioneer 10, the first mission to the outer planets, the first to venture out beyond the orbit of Mars, out through the Jupiter system, and eventually out of our solar system completely. Share now the Odyssey of the Jupiter pioneers. The planets of our solar system come in 2 varieties. The inner 4, including Earth, are heavy, rocky cinders. Where the 5th should be, there's only a band of debris, the asteroid belt. Beyond ride the enormous outer 4, the mysterious gas giants. Astronomers have studied them since the time of Galileo. It was he who discovered Jupiter's 4 large moons with his newly perfected telescope. Beautiful ringed Saturn. In 1979, Pioneer 11 will make mankind's first visit to Saturn. If it survives the rigorous journey of 6 years in time, nearly 2 billion miles in distance. Third of the gas giants, Uranus, rotating on its side, it circles the sun like a fallen gyroscope. And finally, Neptune. One of Neptune's moons, and one moon belonging to Uranus, were discovered by this modern Galileo, the late Dr. Gerard Kuiper of the University of Arizona. His backyard in Tucson has flowers, a swimming pool, and a private observatory. Here at Catalina Peak, his studies have produced some of the most outstanding color photographs ever made of Jupiter from the Earth's surface.
This is sort of a typical photograph which shows the red spot of the planet, which is the most prominent feature. This black spot here is the satellite Shadow, is the satellite Io, which is the nearest of the 4 large satellites of the planet. The satellite itself is here and doesn't show very well contrasted to the planet itself. Now the first thing you see is first, of course, that the disk of the planet is elliptical. That is because of its rapid rotation, which is roughly 10 hours. The period is roughly 10 hours. The diameter of this planet is about 10 times the diameter of the Earth, so it is a gigantic planet. The total mass is not, however, 1,000 times. The volume is 1,000 times, but the mass is only about 300 times that of the Earth. So the mean density of this planet is somewhat like the Sun. And that is because it is largely composed of hydrogen. So the composition of this planet is very, very different from the Earth, and very similar, in fact, to the Sun, except the temperature, of course, is much lower than the Sun. And because the temperature is low, you get a chemistry here, which is totally different from the Sun. So you have all these interesting colors here, and what we have been doing in recent years is to try to understand both the motions of all these clouds and their composition.
Our odyssey to the outer planets begins here at Cape Kennedy. A good omen under a mock Jupiter sunrise. The ungainly, pregnant guppy delivers a special cargo. The Jupiter Pioneers were built by TRW Systems of Redondo Beach, California, under contract to NASA's Ames Research Center. The project involved some 25 million man-hours of meticulous work by the government, industry, university pioneer team. Each marvelously compact and reliable spacecraft weighs less than 600 pounds, including some 65 pounds of scientific instruments. The 11 onboard sensors include 5 radiation and charged particle detectors, 1 magnetometer, and 3 light measuring devices. 1 for the visible spectrum and 1 for either end of the visible range, the infrared and the ultraviolet. There's also an experiment to look for asteroids and 1 to measure the number of times Pioneer is struck by space dust. All of these devices together use less electricity than one 25-watt bulb. That's energy conservation. 2 other investigations dig out new information about the Jupiter system from ground tracking data. The question arises, what can 65 pounds of spaceborne instruments tell us that Earth's finest facilities can't? For example, the famous Mount Palomar telescope with its 17-foot diameter glass eye. A scientist who uses both Pioneer and Palomar is Dr. Guido Munch of Caltech.
We have used the 200-inch telescope extensively for planetary observations. This is the largest operating telescope that has ever been built. With this telescope, the planet Jupiter appears of the size of a 50-cent piece. The Pioneer infrared experiment will provide a map of the heat emitted by the planet with a 3-inch telescope. But at the distance of closest approach, the planet will cover 1/5 of the sky. And this is the advantage that we get from the 3-inch telescope to the ground base with a large telescope here. The need to measure the quantity of heat accurately is that all the meteorology, all the motion of the clouds that we see in Jupiter is governed by the amount of heat coming from the inside. And we hope that a real understanding of the meteorology of Jupiter will in fact provide us with a better way to handle our weather problems.
The second day of March 1972, Pioneer 10 waits for launch atop a new 3-stage version of the Atlas Centaur rocket. Months later, a sister spacecraft, Pioneer 11, left the pad on its long and chancy voyage to Jupiter and Saturn. It's not easy to break out of the solar system. It requires enough speed to defeat the sun's gravity as well as Earth's gravity. Pioneer streaks away faster than any previous spacecraft, gulping distance at 1,000,000 miles a day. passing the moon in just 11 hours. Still, Jupiter is nearly 2 years away. On the way out past Mars, the experiments are tested and calibrated. Their data add to mankind's understanding of the interplanetary climate of space. The asteroid belt, as some had imagined it. Before Pioneer 10, it was pictured as a region where great boulders grind together, creating a 40,000 mile per hour sandstorm. If so, it might have represented a perpetual barrier to outer planet flights. In fact, the pioneers found very little space dust in the asteroid belt. True, there are several thousand asteroids, some as big as Texas, but they should offer no menace to navigation. Pioneer gets its electricity from small onboard atomic heat sources. At 500 million miles, the sun is too weak to power solar cells. The spacecraft spins 5 times a minute for stabilization. On ground command, small thrusters fire to maintain the spin rate and to keep the large dish antenna precisely pointed at the receding Earth. This radio link is a two-way street. A constant stream of information flows back about the health of the Pioneer and its scientific observations. NASA's Deep Space Network tracks the mission. So sensitive are these ears that they will hear Pioneer out to nearly 2 billion miles and lose contact late in 1979. Pioneer is managed and controlled from Ames Research Center located at Mountain View, California, near San Francisco. The Nerve Center is in this building. Pioneer Project Manager Charles F. Hall.
So we're in the mission control area for Pioneer 10, and behind us is the mission control room. Now, right now, they're preparing to send quite a few commands up to the spacecraft, merely to change the attitude of one of the instruments, the operating mode, so that we can look on Jupiter. The interesting feature here is that the round-trip light time, the time to get a message from here up to the spacecraft, and then to get a return answer, is 1.5 hours. So our people in there have to be used to this 1.5 hour delay when they start planning the mission.
Commander R10. Sure, Captain. We just received the stat clear message. Roger. R10 Commando, verify command stack loaded. Block message number 9. First command, IP Whiskey 2, time 141032.8. Roger, copy. We're enabling message stat at this time.
The Pioneers are run by men who send commands from Earth, not by automatic systems on board. This cuts complexity and costs. During encounter, it's busy here. For example, to command just the electronic camera that makes pictures of Jupiter, Pioneer Control transmits some 15,000 commands in just 2 months. In response to these commands, the camera scans Jupiter's turbulent cloud tops as Pioneer spins toward encounter. Because the spacecraft is moving at up to 80,000 miles per hour, and because Jupiter is rotating at 22,000 miles per hour, the scans do not immediately form a pretty picture. They must be decoded and corrected for distortion. First, the scans are built up line by line on a television display. This gives a quick look at the operation of the system and a tantalizing hint of the spectacular pictures buried in the raw data. After the first stage of prettying up, Jupiter's first close-up portrait emerges. Late November 1973, 20 months after launch, Pioneer 10 closes in on Jupiter. Each hour brings the planet 20,000 miles closer. What lies below those inscrutable cloud tops? Could there be life in this maelstrom where pressures may reach 200,000 times Earth's? There are scientists who think that the answer might be yes, that deep in this raging atmosphere of ammonia, marsh gas, and helium, the self-replicating spark may have been struck. One believer is Dr. Carl Sagan, of Cornell University.
Jupiter has an atmosphere rich in hydrogen and its compounds, the same kind of atmosphere that the Earth had at the time of the origin of life. So we think that the building blocks of life, at least earthly life, are being produced on Jupiter today, raining down from the skies like manna from heaven. And Jupiter may be a vast planetary laboratory in the chemistry of the origin of life that's been working for about 5 billion years. It's by no means out of the question that there are forms of life in the clouds of Jupiter. And indeed, if you viewed the solar system from afar, I think you could make an argument that life on Jupiter was more likely than life anywhere else, including on the Earth.
Dr. Sagan also provided for Pioneer the famous picture postcard to extraterrestrial life.
But in the remote contingency that there are interstellar spacefaring societies which might someday pick up this derelict, no longer radioing, we thought we would put a message on it to indicate a little bit of where we are, when we are, and who we are. We think that the information on where we are and when we are, indicated in this part of the message by the configuration of certain cosmic objects called pulsars, will be completely obvious to any society capable of traveling between the stars. These two objects will be more mysterious because it is unlikely that there will be human beings anywhere else, even though there may be other creatures elsewhere. And the plaque has served a very useful purpose in making us think about what sort of impression we might wish to give to the cosmos.
Each morning, the key scientific investigators and the key spacecraft personnel meet in the office of Pioneer Project Manager Charlie Hall for a stand-up meeting. Why not a sit-down meeting? Because, says Charlie, people don't talk so long when their feet get tired.
So like a contrast, I guess is a better word.
I have the impression that it is all in the fix. I don't know for sure that it is all in the fix.
Yeah, with such accuracy, but just grossly whether we can trust the angles on the LCD. I'm afraid to say anything because I don't know. We'll have to get to...
Say 250 degrees or something like that in System 3, which is not far from what the radio astronomers inferred.
We have 3 sets of accurate observations with the IPP this week since the last precession maneuver.
What we're seeing here is that for both electrons and protons, we're seeing in first approximation an in-phase change.
But don't you know, you're not pretty good. No, it's all right. You're going in pretty consistently. Yep.
December 2nd, 1973. Tomorrow, Pioneer will make its closest pass of Jupiter, when this fantastic world will fill 1/5 of the sky. Today, Pioneer is being cooked by incredibly severe radiation, yet everything continues to work perfectly. This spectacular picture shows the shadow of the satellite Io, just as Dr. Kuiper's ground-based photo did. But from this distance, new details in the cloud bands become evident. Huge coiling storm areas larger than the Earth. Since launch, Pioneer has been slowing down. Now the pull of Jupiter's gravity speeds it up to a fantastic 82,000 miles per hour. In effect, this crack-the-whip left turn gives Pioneer another rocket stage to fling it out of the solar system. Unexpectedly, the space dust count soars, 100 times as many hits. Jupiter's gravity may act as a cosmic vacuum cleaner. December 3rd. Pioneer sweeps to within 81,000 miles of the cloud tops. Now things happen fast. 15 minutes after closest approach, the spacecraft is targeted to pass out of Earth's sight behind the orange moon Io for a critical 2 minutes. This ultra-precise maneuver will use radio effects to reveal new information about Io, if the signal can be picked up again on the other side, and if Pioneer will obey commands again. Back at Mission Control, there's a maternity hospital atmosphere. They won't know what happened in space until 45 minutes later. The speed of light is much too slow for the anxious parents.
What kind of an illustration do you want to get? What kind of
Future missions. We have observed the planet in the infrared. We have observed the planet in the ultraviolet. We require the actual probing of the atmosphere.
did go behind you.
Oh, we lost it?
No, yeah, we went out of lock and we were less than 1 second from plan.
And you're back. You're not back on.
No. Oh, I say that's an extra trajectory.
I'll give you the time in a second.
Oh, we missed the EO occupation by 1 second, and I was just sort of kidding him or telling him that you have to go through the ecliptic at the right time. When the EO goes in front of you, we're 3 Jupiter radii away, EO 6 Jupiter radii. You got to get all this thing lined up, and we missed it by a second. Next time we'll do better.
An hour later, Pioneer passes out of sight of both Earth and Sun, this time behind Jupiter. The spacecraft is collecting its worst radiation exposure now. Tension is even greater this time. And so is the relief.
Norm, how was it? Very good. We came out just a little bit later than we expected to, about 40 seconds later than we expected to, but everything worked fine. We went in about 14 seconds later. All the instruments are operating just like they were when they went in. Came out exactly the same way. We're very pleased.
Gee, you're late again. It's pretty good for government work, Dr.
Makes it all worthwhile. It's after 10 years of having to put up with all these people, the 14 hours a day, it's all worthwhile.
Now Pioneer views a sight never before seen by man, the crescent Jupiter. From Earth, we can see only its full phase, like a full moon. These lighting angles give scientists new information. On the television system, the images rapidly become smaller. Now several consecutive pictures can be stored on the tube at once. Thanks to energy literally stolen from Jupiter, Pioneer 10 departs more than twice as fast as it arrived.
Early this morning,
Now the world wants to know, what have we learned? The scientists readily admit to newsmen that for each question answered, 100 new ones have been raised.
2 different phenomena going on.
Project scientist Dr. John Wolfe reports.
Approximately 44 Jovian radii. We had the indication of very strange plasma distribution.
We're taking back with us to our laboratories data which essentially are puzzling to us and will take a long time to work out.
Some points are clear. The whole Jupiter system is heavier than we thought, by about the weight of 2 Earth moons.
Our most important finding to date has been
Io has a thin atmosphere. Thus, Jupiter's 4 large moons probably all have atmospheres.
Seeing relatively abrupt decreases in the field magnitude to much lower values.
A compass on Jupiter would point to the South Pole instead of the North Pole.
Through the magnetosphere.
Experiment.
The infrared experiment successfully mapped Jupiter's heat in fine detail. The planet gives off more than twice as much heat as it receives from the sun. Why? Possibly its enormous gravity makes it contract like a slow-motion star. The white belts are cooler, and therefore higher bands of clouds stretched around basically darker-colored material below. Also, the night side and the day side appear the same temperature. Discoveries like these flash out to the world. To experimenters, some of the most interesting findings concern Jupiter's radiation belts and magnetic field. Pioneer first broke into the magnetic field an incredible 4 million miles in front of the planet. Because of the pressure of the solar wind, this field streams out much farther behind Jupiter. Closer in, Pioneer indicates that Jupiter's intense radiation belts wobble up and down around a magnetic center some 10,000 miles from the center of the planet. In brief, Jupiter is much different from Earth and much more complex than researchers imagined. However, Pioneer proved that a spacecraft could survive the radiation. After encounter, The data tapes for the imaging experiment go to the University of Arizona for computer enhancement. In a meticulous process, millions of data points are juggled up and down the scale. And what emerges is a portrait of Jupiter to challenge the most imaginative artist. While Pioneer 10 journeys to the edge of the solar system and beyond, the information it returned has permitted Pioneer 11 to be redirected to not only pass closer by Jupiter, but to continue on to the next outer planet, Saturn. If all goes well, Pioneer 11 will reach the ringed planet late in 1979. And if it returns pictures, we will know much more about those glittering and mysterious rings. Mankind will continue to explore the outer planets, and sometime in the decades ahead, a robot explorer will descend on Io at the end of a solar eclipse by Jupiter. The sight will be one of the most dramatic in the solar system. During its hours in the freezing Jovian night, Io's atmosphere snows out onto the barren and radioactive terrain, then flashes back from solid ice directly into gas in the span of a few moments. The domain of the outer planets is majestic beyond comprehension. The pioneers, first to brave this land of giants, first to fly forever among the lonely and endless stars of our galaxy, carry mankind's message. We're on our way.